Okay, in this next example, we're trying to use a known limit to determine another limit. Now, where did we see this before? We actually evaluated this limit numerically, right? So when you have sine x over x and x is in radians, when you plug in into your calculator sine of 0.1 over 0.1, sine of 0.01 over 0.01, you keep making these x value close to 0, you'll see that this ratio was, we saw that this ratio was close to 1 as we made x going to 0. That's what we figured out in the last class. Okay. Now, so actually from now on, this will be an accepted limit. We will always consider the following as a known limit. You can always use this even during the exam without having to show it. Now let's try to see how we can use this one. Okay, the idea is you multiply the conjugate of, I'm kind of abusing the word conjugate. Originally, conjugate means when you have a complex number, you change the imaginary part's sign. That's called a conjugate, but people abuse it to say, oh, if you have two terms and you have a sign, and changing the sign, you call that a conjugate. So that's what I'm saying when I say conjugate, but that's actually an abuse of the terminology. Okay? But the idea again is to multiply the conjugate. Now, how does this help? It helps because if you use this a minus b times a plus b equals to difference of two squares formula, then you get 1 squared, the square of the first one, minus the square of the second one. And then you have x squared, 1 plus cosine x. Okay, does anyone know any formula related to 1 minus cosine squared?
Sine squared plus cosine squared equals 1.
Yeah. So I guess I want to put all the formulas here that we're using. So this was one formula. Another formula that we're using is sine squared x plus cosine squared x equal to 1. And this in turn says that cosine 1 minus cosine squared x is equal to sine squared of x. So I can replace the top by sine squared of x. And then, therefore, sine x, I can rewrite this as sine x over x times 1 over 1 plus cosine of x. Now, please check that this is indeed same as before. Right? What does sine squared x mean? It means sine x times sine x. Right? So if you simplify the top, 1 times sine, it will give you sine squared of x. And if you multiply the bottom, 1 plus cosine x times x, you do get that. So these are indeed equivalent. But why do you think I wrote this in such a complicated way? Because I know that each of these sine x over x's, they're going to converge to where? 1. So this will become 1, that will become 1. Where would this one converge to? Well, are you allowed to plug in 0 to cosine? What's cosine 0? 1. Okay. If you forgot, I'm running out of space to draw, but here. Cosine graph starts from 1. That's the graph of the cosine, right? So at cosine 0, it's 1. It comes up very frequently, so you should memorize this along with the graph. Okay? So every time you see cosine 0, think about this graph. At the 0, what's the value of cosine? It's 1. So it's 1 over 1 plus 1. So you end up with 1 over 2.